Hi, Benoit. Hi, Matt.
Hello, Thomas.
One question on the data tracker, the meeting minutes box. I cannot click on it.
Oh, okay. Can you drop an email to IETF-action? I'm uploading a PDF for version 4 of Arga.
IETF-action at IETF.org. Huh? Okay.
Right. Matt, I would like to make sure that you can speak and we can hear you in this meeting. Matt, I see that you're connected in the chat, but I can't hear you.
Is it better right now?
Yes, it's better.
Yeah, okay. I think we can start, Benoit.
Okay, very good. Can you share the chair slide? I would appreciate. All right, very good. So thank you very much and welcome to this meeting. So on behalf of Matt and myself, co-chair, but also Thomas as secretary, welcome to this meeting. So Network Management Operations. This is jointly done with TEAS. TEAS is the Traffic Engineering, Architecture and Signaling. They've been doing some topology work, as we're going to hear from Italo. This is a joint meeting because there is some, we want to evaluate whether one of the RFC written by TEAS, which is RFC 8795, Young Data Models for Traffic Engineering Topologies, could be a good basis for digital map. So it makes sense to have these joint meetings. Note as well, this is a regular meeting, so this session is being recorded. And if we go to the next slide, this is only the second meeting we have. So there is a note well on the second slide, yes. And by participating in this meeting and the IETF, you agree to follow the IETF process and policies. And if you are aware of any patent or patent applications that you own or someone else own, then you must disclose it not only at the adoption time, but at any point in time during the life of the document. And you acknowledge as well, a little bit too fast, Matt. I don't know the note well by heart. So if you could go back to the previous slide. So you acknowledge that any activity could be written, audio, video, and photographic record. It could be made public. And that the information you provide will be handled in accordance with the IETF policy statement. And obviously treat each other with respect, otherwise some actions will be taken. And there are some supporting documents that you might want to read. Thank you. Then there is this agenda bashing here that we're doing now. There is one part which is about the NMOP. So it's going to be a combined session by Olga, Oscar, and Nigel for a small hour. Then there is like the TEAS part, which is done by Italo. And then we want to keep 15 minutes for next steps and wrap up. So any agenda bashing so far? All right, so hearing none. So on the next slide, so do you want to take it from here, Matt?
Yeah, I can do that. Yeah. So yeah, the first part that will be, I would say, more focused on the work which is conducted here in the NMOP. There will be a summary of the action points that we agreed last time during the last IETF meeting. There is the analysis which is conducted by Olga and the team. So you will be sharing the conclusion and the analysis that you have made so far, and then the plans for the hackathons and the experiment that will be conducted in the next IETF meeting. Yeah, so for part two, this is what Benoit mentioned. This is what we call the TS working group part, even if not formally we have the joint meeting, but anyway. So this will be an introduction to the T topology model, so that everyone is aware about the, I would say, what this model can do. And then there is the ongoing profiling work, which is then also in the TS working group. So Italo will be sharing how this can be used for including no T topologies. So that's for the agenda. So there are some, I would say, some minor, not minor, but important aspects also that that we need also to take care about, is that the initial work about the topology was done in the within the routing area, and so we informed at least all the routing area director that we are doing this work. So if there is any I would say objection or guidance on their side to involve other working groups, that will be really something that is welcome. And we also contacted all the authors of the original, I would say, RFC 8345 to let them know about this work, invite them to contribute and join this effort. So we just received some positive support that this work is needed, but without commitment to contribute. This is for just to focus that in this NMOP working group, we really insist on the running experiments. So we really value and welcome competing experiments and running them. We don't have so far no conclusion about how the digital map will be modeled, but so that's why we would like to have this discussion in this interim meeting. And we really welcome new use cases and challenge the analysis that has done so far, so that we can have more, I would say, voices from operators, but also from the vendors. So that's the at least the main point that we wanted to cover during this meeting. So I think the floor is yours now, Olga, to present the first part of the meeting.
Thanks, Matt.
And while you're preparing the slides, Olga, do you prefer to have questions towards the end or in between? What do you prefer? You've got the time slot for the three of you. You decide.
Yeah, like I think it's okay to ask any questions while I'm presenting. You know, if they're specifically about something. If there are more general questions, we can leave them for the end.
Yes, so you could ask to share this slide that are preloaded, Olga, if you wish.
Oh, sorry. I thought you are sharing the slides. Sorry. Yeah, okay.
So while we're doing that, you have a small button at the bottom of the screen if you have any questions. So just click on Join Queue, and Olga would see that, and the chairs would see that as well.
So I asked for sharing. Did you get the request?
Yes.
Okay. Can you see my slide?
Yes.
Okay. So this is the presentation between Oscar, Nigel, and myself. We prepared the agenda and discussed the content of this presentation together. And also Nigel's part is a separate presentation that he will do after this one. So we are talking today about continuation of what we presented before about RFCA 345 gaps for digital map modeling and what our current status is in different drafts related to digital map and about our IETF 120 plan. So this is the high-level overview. The goal of this presentation and the meeting in general is to structure the work and exercise the plan presented at the last IETF so that we don't kind of leave it to the end. The following are the topics that we will discuss today. Oscar will present the problem space as a refresh for new audience because this has already been presented few slides. Then also kind of the summary what we presented as the new steps, as the next steps for IETF 120 that we presented last time. And then for the status, we will present progress of the analysis of RFCA 345 augmentations and some of the conclusions, initial conclusions. We would share our plans for IETF 120 drafts. Myself and Oscar will share that, and then some initial plans for the hackathon, and also suggestions. We will talk about our plan is also to give some suggestions and IETF about more specific requirements that can be used for agreeing the approach and guidelines going forward. So this is the high-level overview. Oscar, do you want to present the next 2 slides?
Yeah, I can go with it. Hope that you can see me and hear properly. So also, I mean, this was already presented also in last meeting, but just to refresh, what we want to do here is to be able to represent our real networks. Okay, so it's not just it can be abstractions, it can be different specific part, but here mainly is to use Yang to represent the carrier's network. And what are the use cases that we have for this? So here, what we want to do is to do analysis of our network. So, for example, one of the particular use cases to do the capacity planning. Also, another use cases is to be able to run the what if analysis. Okay, so we have the representation, we can run them, and the ultimate goal that we have for this whole digital map is that the digital map is the basis of the digital twin. So, okay, you get this representation of the network, you can feed it, and then you can somehow emulate. Okay, so here, as we didn't want to boil the ocean, okay, so here we just start by a very simple task is, hey, how can we use the IETF topology model and surrounding models? Okay, so is the current model, T model, L3 model, etc. to represent a very, we start with a very two tiny use cases, okay, very specific ones. So is we have our networks, we have the different networks in Telefonica, and one of them are based on ISIS, others are mixed on ISIS and OSPF. So this, we wanted to represent this combination. So we created two drafts, both are uploaded, even the second one is also uploaded, which are just are very tiny additions to what we already have. Okay, so can we go to the next slide? So here, the main, also one of the issues that we all of us that are working in this topic is that the topology is widespread among, I don't know how much was the latest count, if it's almost one the 10 order of magnitude of 10 young models with a lot of augmentations, with relationships, covering many different aspects, and it is, let's say, to be honest, it is always hard, okay, when trying to model a specific or to represent a specific use case. I mean, the buffet is very big. Okay, so you don't know what to pick. If you go to the salad, if you want to go to the chicken, you don't know where to pick from. So here, when we go and we try to do the exercise, okay, we want to model our particular network. Okay, so we said, okay, we start with Telefonica network, for example, and okay, we say that most of the parameters are here or there. There are some gaps, and the way that the topology, the IETF topology is built, it requires you to do some tricks here or there to be able to play. So, for example, here the domains is some abstraction. I mean, domains in reality they exist or not exist. I mean, these abstractions that we create, that we humans create, and we said, okay, for us, a domain can be, for example, all of the routers that are talking the same process. But in the end, the organization could be something different. If you see, for example, when talking BGP, for the domain at BGP can be different than the domain at the IGP. Even several together for administrative purposes, maybe under different domains. So even the domain can change. Okay, so the definition can change. So here, what we see is that it is possible to model the same network even with many different ways, and you can have multiple views of the same network using instances of the network concept in IETF for every of what you call domain. That will be particular for your use case, because the term domain can vary from one representation to another depending on your particular use case. So with this, I finished the part.
Thanks, Oscar. So this is the summary of next steps that we presented at IETF 119, and I just wanted to do a refresh before we start talking about our progress. So for IETF 120, we will start working on RFCA 345 bis to include the changes that we are proposing to both IETF network and IETF network topology modules. We already shared the gaps. I will refresh later. And are identified in the draft digital map. And our goal is to provide some simple backward compatible solution for these limitations and propose them in the A345 bis draft. And our proposal was to start from draft Davis NMOP, some refinements, and also to look at how RFC 8795 did some augmentations, and also look at other existing augmentations. So we are currently doing analysis of those augmentations. And then the goal is to start with the POC. We are not claiming that the IETF 120 will have the full functionality done, but we will start with the hackathon. And we already had a POC and we shared with some of you some results, and the draft is based on that. But we are now moving to the hackathon with the latest version of the drafts, with others being involved. And we want to implement all of these proposed changes during the hackathon. And we will start with few of them at IETF 120, and there will be more details later during the presentation. We also started, in fact, working, and I would say that we did a lot there in terms of analysis and categorization of the RFCA 345 augmentations. That was the plan, and do some categorization of different extension categories. And as we presented before, is that these augmentations are not consistent, and it makes it very hard to deploy the multi-layer digital map using the IETF topology approach because of different types of augmentations and different approaches that we tried to understand, analyze, and categorize. And what we also discussed is that we want to have a joint meeting, and this is the starting point, but we would like to have a face-to-face with TES and to discuss, different approaches, A345 versus 8795. So this was our plan from IETF 119. And today I will start with talking about the status of our augmentations analysis. I first want to go back to why kind of we decided to do this exercise, First is we want to know whether RFCA 345 is the right starting point for modeling the digital map, and is it sufficient to understand the layered topology? We didn't want to look at all the different properties, attributes that we need for different use cases, although we did define the highest priority use cases as Oscar mentioned. But the goal was really to kind of see whether A345 is sufficient for modeling topology for different use cases and whether it can support layers, generic topologies, relations between them, and is it, the right way to do it. The important thing, I think, for all of us is maybe to kind of agree what was the goal of the RFCA 345 originally, and I personally think that the goal was is to be able to present any type of topology for any type of use case in a generic way, so that applications don't have to understand all the details of different functionalities and attributes. So this is the quote from RFCA 345. The data models allow applications to operate on an inventory or topology of any network at the generic level, where the specifics of particular inventory or topology types are not required. At the same time, where data specific to a network type comes into a play and the data model is augmented, the instantiated data still adheres to the same structure and is represented in a consistent fashion. For me, this means if you augment, you add your additional attributes, but don't change the structure and continue to represent your topology in consistent fashion. To me, this means reuse TPs, nodes, networks, and links, and don't introduce additional topological entities. That would be the reuse relationships and supporting relationship that you already have there. Maybe don't introduce your own ones that I have to understand only if I augment. So this also facilitates the representation of network hierarchies and dependencies between different network components and network types. So I think this is important quote from RFC 8345, because if we are not following this kind of principle, let's call it, is it really feasible to expect different applications to understand numerous augmentations in order to understand the basic layer topology for either single or multi-domain? So I think this is a question that we should ask ourselves. And I think Oscar already did talk about it in a more specific way, but I'm talking here more about, generic way and how the applications could use that API in order to understand and draw those topologies. So we can see the approach of IETF. They said, okay, this is RFC 8345. We are proposing generic topology model, and please augment, add your own things, either technology specific or for use cases, but reuse topology. And my understanding was I want still to be able to draw the full topology using the abstract topology model. And they are giving examples of different technologies. This is one example from the draft with physical layer 3 and service, but it can be done at different levels, and they have examples of VPN tunnels, etc., and all of it. So I just wanted to do refresh of the draft because I think it's a very important principle from the draft. Any questions? So for us, then the goal was to do high-level analysis of all the modules that augment the RFC 8345 and understand some high-level points. What is the purpose of each augmentation? And there are different reasons. Some they're adding some additional information for some specific functionality like traffic engineering. Others, they're adding information about specific technologies like layer 2, layer 3 topology, ISIS or SPF. And is it augmenting to connect to some other modules like we have inventory and PM? So these were kind of some generic questions that we wanted to answer. Also, in the way how it is augmented, we want to understand, is it just by adding attributes, events, different types, maybe some new relationships that are non-topological, that have no impact on topology? And if that is the case, then layer topology can be fully understood and drawn using the RFC 8345. Or is it by adding its own topological entities and topological relationships on top of the existing ones? And this one has a full impact on RFC 8345, because then we cannot use RFC 8345 without the changes to model the layer topology, without understanding those augmentations. And then there is the third one, when some semantics is being added in a non-generic way, and sometimes that semantics is really applicable to many different augmentations, but it's still not something that breaks the topology, because you don't have to draw, like, say, the specific roles like hub and spoke. Or so layer topology could be still understood and drawn, but roles and more and some other information about topology cannot be fully understood. So we started working on this analysis, and Nigel and myself are collaborating. We have a Google Sheets done, and we are working through all the augmentations. And Matt suggested to move it all to the public space so that we can get involved others. and get some kind of feedback and contribution, because the analysis effort is quite big. So we added it to GitHub. So we would really, I will show you the Excel spreadsheet at the end of this slide, and maybe give you some kind of indication about things and answer any questions you have. But please add your comments via issues, pull requests. It's highly appreciated. We had already some comments, like Bo reviewed and contributed for her modules. Mad reviewed his modules, and we have some meetings planned to add more reviewers and contributors. But really, it would be appreciated if you could support.
So there is one question from Nigel.
Okay, yeah, sorry.
Thanks, Benoit. I was going to leave it to the end now, so I'd sort of given up. But that was on the previous slide, actually, Olga. If you want to go back to that, I've got a very strange. Yeah, thanks. That one, you were talking about topologies and topological structure. I think we need to be very careful to recognise that there are essentially two topology levels or perspectives, or in a network layer, or what you want to call it. One is the topology of potential, which is very much where RC8345 focuses, with links and termination points. And then there's the topology of use, where you've got a specific flow that's been enabled. So you've got a constrained enabled flow. That's also topological. And I've certainly seen situations where the same entity has been used for both the potential and the enabled flow. And I've seen situations where different entities are used. And I think the T solution is a solution that assumes there's a distinction between the entities for enabled flow and the potential for flow. And that, I think, is where this challenge comes in. Are all topologies represented by 8345? So whether we're talking about the potential for forwarding of information, or talking about the actual, or is it only about the potential? And the word link tends to lean towards potential, but only lean towards it. So I fully support Oliver's point here, but I think it's more complicated than simply there's topological stuff, and it should all use 8345. I think we need to be careful, but I do agree with what I was saying, certainly on the slide.
So is your understanding that the goal of 8345 to be potential only?
No, it's not. No, it's ambiguous. that was my point. It's ambiguous. And the choice.
When you say it's ambiguous, they were talking about topology. And topology may be planned, maybe historical, maybe, why would you decide to have different models for different?
It's only the only thing I'm picking up on here, Olga, is the usage of link in bodies like IGT, where the link is only about potential, and hence if you use that term, it tends to lean the audience towards the thinking that it might be potential if they've got that background. It doesn't need to only be potential. I fully agree with you, but it's just terminology like that tends to blur the issue a bit.
I understand it perfectly, because as you remember, Nigel, we did kind of, I don't know, 20 years ago discussed it all, and there was that complications of different. We did it in different standards, and
I know.
Included simplification and going back to the more generic one would be kind of easier. And we started with having separation. We started having separation, but of course, you're absolutely right. There are two approaches here.
I wasn't disputing anything you were saying. Sorry, no. Yes, I have got that background in my. I'm not going to share today, but maybe we can talk offline. Olga, I've got a slide pack that tries to show the various different usages of topology, where you could say it's the same single thing recursed or separate things and so on. We may want to talk through that and see if that helps clarify the issue. It may not. It may blur the issue, but maybe offline we can talk through that and then see if that could be something we use in IETF 120 as an additional sort of insight in this area.
Okay, thanks, Nigel. No, I absolutely agree with you. Like we know from different standards, other standards that probably kind of had that approach, and they wouldn't use links for some of those things. But my understanding, based on reading RFCA 345, maybe I missed something, is that there was no distinction between planned and the real existing topology, and that they were kind of proposing to use a generic approach.
I don't think you miss anything. No, I think it's just ambiguous in the sense of the terminology usage, for example, leads the reader to a particular point which may not have been their intention. That's the concern.
Exactly. Yeah. Thanks.
So one thing I would like to stress, maybe you've not seen the notes from Matt, but I fully agree with it. Whenever you mention let's get offline is just offline of this meeting, right? So it would be better to have it on the mailing list, which is somehow
that's fine.
one of the issues that we see
meant,
that
yes,
there is not enough discussions, right?
My,
so
my
please
bad,
on the
yes.
mailing list.
That's what I meant. Yes.
Thanks. Sorry, I don't see the messages when I'm sharing. So.
Yeah, there's also one comment from Brad. I don't know, Brad, if you want to, I would say to get the mic to express your comment, or you just find the note that you have made on the chat.
No, I can't actually see the slides, so it's hard to comment. I've tried multiple different networks and multiple different PCs and multiple different operating systems, and they all show the same thing. It's just screen shares being started, and there's no actual display of the screen. So that was makes it hard to contribute when can't see it. But I've run out of PCs and networks to connect to try to see it, so it's fine.
Okay, thanks. Yeah, Olga, please.
There is meteco-support. I believe this is the right mailing list. I'm going to send it now to you.
Thank you.
Thank you.
The slides are available. Sorry, Ben, to interrupt. The slides are available, aren't they? So Brad could perhaps pick the slides up and try and, if he can't fix it, follow simply by reviewing the slide material. So in parallel, that might work if you can point into them, maybe.
Yeah, that'll be a good option. Thanks, Nigel.
So, thanks. Thank you. So we added this analysis on the GitHub, and here is the link. And we would really appreciate if you guys can give us any comments or feedback, or if there is anybody who is interested in doing contribution in terms of picking some of the additional ones that are left and finalizing the analysis. But if you go to the here you can see on this GitHub the augmentation Excel spreadsheet that was generated from the Google Sheets that we are using to collaborate at the moment. But review comments could be done based on this Excel sheet. So here is the example of this Excel sheet where we have different modules, and I will show you some conclusions and statistics about these modules. We have different, with authors here, then there is a status, whether it's done or it's still in the initial analysis, I would say, because real analysis would be when we get more feedback and maybe go second time through some of these. Then we try to split it into functional, category, and technology to understand, is it just topology related? Is it generic? Or do we have kind of functional category like traffic engineering, which is still generic? Or do we have topology which is specific? Some of them would not even be topological thing, but maybe PM and inventory, which are linking those to the to the topologies, or topologies linking to PM and inventory. Sorry, this is SAP, but inventory is both topology and inventory. So we try to go through the first pass of these categorization to understand, is it generic or not? This would be the type of the network that is defining the augmentations. This is if the presence of this container would determine that this type of topology is being considered. And then what we found is that a lot of them shown in the Young catalog on the picture that Oscar showed are either deprecated or expired. So it was not explicit in the Young catalog. We had to go through them individually too. And all of them are IETF except BBF, which is a good one because it's called digital. It's called the digital map, and it is the one that is using this topology, network map, and it's using this topology for its own purposes, for the proper Google type maps and functionality in BBF. This is the draft or RFC. Maturity, please don't disregard it, maybe because we are using the catalog, but some of them are not correct. And then we try to see which ones are augmenting, and maybe it's not augmenting because this is based on import, so some of them are augmenting, but some of them are just using the types. So here it's what's imported or augmented. Is it just IETF network? Is it just also IETF network topology? Or is it TE topology? So to get some kind of numbers here around different augmentations and imports, and these are the categories that we identified. So any comment from you guys would be welcomed, but I already mentioned these attributes, events, new relations. They are the ones that would not have impact on the topology. You can still draw it without. And then there are the others who add topological entities, relations, that are kind of where you would not be able maybe to show the full layer topology without going and understanding the other augmentations fully. And then the semantic role one, and also there was a case for some sublayers. It was just one draft which defined the sublayers in a different manner, and there are some which just use types, so that was really not a topology. Some of them were just using IDs without even leaf refs, just types. So we also tried for those ones that we kind of identified, to understand which topology concepts. So these are more like nodes, but nodes that we can use to understand what are the topology concepts either reused or added to the. So this is really kind of the high level summary of this analysis.
Olga, I see that Italo wants to comment. So please, Italo.
Okay, thanks. Hi, Italo.
Hi, Olga. Okay. I started to review an old version of the digital map, but it was very old, and I made already some comments on GitHub, but we can work offline later. Another question I have is, you speak about the specific application for TE. Do you have an idea about the boundary of what is specific to TE and what is more broader than TE? I'm thinking about some interesting use case I heard about using SRLG for a what-if analysis also in a connectionless network. Do you think so the technology is clearly non-TE. Do you think this is a TE application or not?
In the case of what if, there are different aspects. There may be aspects in terms of TE, but there may be aspects. What about symptoms? What about assurance?
Oh, I agree, but I'm thinking about some attributes which are rooted to TE, like SRLG, shared listening group, which may be useful for what if analysis in non-TE networks. Do you think this is a TE application or is it a non-TE application? Yeah, it's important to understand when you say it's only for TE, there is a boundary of what is only for TE, which is very blurred as far as I can hear.
No, is your comment here, you are talking about very specific, is your comment here that this functional category is not TE, but it's wider than TE?
Yes, it's wider than TE.
Okay.
Yeah. There are many aspects like this.
Okay,
many
but
aspects
called
like this.
TE, so I just called it TE because it is called TE, and if I look at the definition, if you look at the description of the Young module, it says for representing, retrieving, and manipulating TE topologies. So this is copy paste for me, so that's why I put it as a TE. I'm not saying that you can't use it for other purposes, but the draft says it's for TE. But I'm sure that if you use it for other purposes, that would be great. We can put it in the notes and indicate that it could be potentially used. I don't have, this, I didn't put this as a kind of my opinion. I really used the draft itself to put it. And the reason for this you know, we can put additional ones if you believe it could be additional. I'm not I have no opinion in that respect, except that I was following the definitions in the descriptions in the draft and descriptions for the young data modules in the drafts themselves.
Fair enough. I think it's maybe some clarification that is needed. I think you're right. Okay.
Okay, thanks. Thank you. So here are some conclusions at the moment. Sorry, I should probably go a little bit faster to give time to Nigel and Oscar. So these are some conclusions of this analysis. Young catalog was initially used. As I mentioned, we need to do manual evaluation, deprecated, expired, is it augmentation or import for other purposes. Current numbers, we have 106 modules relevant for topology. This includes the basic 4 ones for the network topology, and there are 27 deprecated and 24 expired, so we came with 55 active, but there may be more. That's why I asked on the mailing list, you know, for some of you guys who are authors, you can just quickly go through the list and you will see straight away that something is missing. You know, so if because this was based on the young catalog, so if you please find that anything is missing, you let us know. So we finished analysis of 41, initial analysis 11 are still outstanding, and out of these 44 initial analysis, we have 7 that are just importing IETF network and not IETF network topology. The rest are importing 38 up to 37 are importing IETF network topology, and we have 9 that are importing IETF topology out of these 44. But I do believe that 11 that are outstanding, maybe a lot of them would support, would import T topology. But out of 44, we have 9. And 8 out of these 44 are adding new topological entities, and 10 are adding new topological relations. So this is some kind of summary of the conclusions in terms of where we are. And for some of them, we can understand fully layered topology, like for layer 2, layer 3 unicast, layer 3 ISS, layer 3 OSPF, BBF network map, IETF SIV6, and IETF microwave topology. I think we can draw and understand the topology and the layer topology. We can do partial topology. Remember these 3 categories. Partial topology just based on RFC 345. We can do T topology, T nodes, LTPs, T links. But when we go to tunnels, there was no TTPs are not using TPs in the original topology. They are added as containers, same as tunnels. We have different underlay relationships, and we have connectivity metrics. So these are the concepts outside of the RFC 345 topology. Another example would be for fabric networks, for example. They used its RFC 8542. They used fabric network, fabric and fabric TPs are modeled as RFC 345. But then when they did go into topology inside the fabric itself, then they introduced new concepts as embedded containers or lists like device nodes, device links, device ports, which are completely outside of RFC 345. So these are 2 examples where the topology was augmented by adding a topological entities. And I think a spreadsheet has the full information about it. So we do believe augmentations are not consistent, which makes it very hard to deploy, as we mentioned, multi-layer digital map. If you are the application that wants to draw the map of multi-domain, multi-technology, or even single domain multi-technology, it would be difficult without understanding details and different lists and different containers of all of the augmented to understand the basic topology and the layering. So this is some conclusions that we had. Any comments, any questions there?
Yes, I've got one comment. So you're trying to get feedback on the Excel spreadsheet. What would make sense? I've seen feedback from Hubo, and Italo mentioned that he provided feedback. What would be nice is to have an extra column which is kind of validated by the author, right? This is the conclusion that you wrote there are validated. So that just expresses that people, because you mentioned that TE is based on how you read the draft, right?
Exactly.
Italo had a different comment, which is could be used for TE or not. But depending on the criteria, just telling it's validated by the author would be great.
Okay, thanks. Thank you. That's very good idea, Bernard. We will add the column for that. So then next we'll talk about the plans for the drafts and some new and what we plan to do for the RFCA 345 bis. So Oscar, do you want to go back and do the
Yeah,
plan?
no, this is very quick update. So here, as you know, we have for both drafts we have them implemented and running in our network to get information to the planning. So and also there is this POC also running also from Olga. So what we want is to get feedback from all these implementations. From the use of the models and see gaps, improvement that we need to have over these two models. Also from the working group, we expect more feedback. So we have unified the repository to collect all the both drafts in the same place, so use it to raise any issues. Yeah, and among the points that we wanted to clarify first is one of them is the relationship with the T topology and the layer 3T topology. Because here in the picture that we had in the first draft, we just mentioned the original topology, not these ones, and well, when you use it in reality, it is a combination of all, really a combination of all the topology model plus these QTings. Okay, so we want to clarify that it uses those, and also we wanted to add JSONs with examples, okay, based on the real network scenario, so you can see how to represent it. And there are some open issues that we want to close, but among them, one of the issues that was still open and is if, for example, for the SIS case, right now we are modeling domains, understanding domains as all the routers that participate, okay, in the same process, regardless the area that they belong to. Okay, so you could further enhance and you can further create another view with this area. So can we model the areas? I mean, that's an open question. And how also do we model the areas if it's another network or we have new relationships? If we need to have, we want to have other type of relationship, we would need to go for the augmentations and publish the new versions with these issues. So this is fairly quick, the plans for the next month.
Thanks, Oscar. So I'll try very quickly to go through the rest. So for the plan for digital map draft for IETF 120, for the one sharing experiences, is to close any issues. There is currently one issue that I've seen that Med raised. Italo, you mentioned you raised some issues. Like if there are anyone else, please review and create pull requests or issues on the draft. Then we would update guidelines with more content based on the results of the analysis. So we would try to put some conclusions of the analysis in the chapter 6, and then we would based on the guidelines, and the summary would be in chapter 7. So these are the two chapters that we would be working in. We haven't started updating it yet because we are still finalizing the analysis, but this is the aim for the IETF 120. And this is for the authors. Med already mentioned this. And our goal would be to add some initial RFCA 345 bis GitHub, so to be able to do some diffs and to present what we are proposing. Like, I don't think we'll be submitting anything as a version or anything, just kind of presenting some things, what would be maybe potentially needed for diff table of contents, some textual changes, because some of those limitations have sections or they have a paragraphs indicating, that they were intentionally there, so they would have to be removed. Some textual changes for additions may need to be added, and of course, young changes. And we are proposing to start with young changes based on Nigel's draft. So I won't go again through these gaps. We went through it several times. So this slide has already been presented, and these are the gaps that we identified in the RFCA 345 with different candidate approaches that we identified. And then the proposal is start working on the backward compatible model. So we are now looking at first 3 steps, maybe for some effort that we are doing for the IETF 120. We would also have a side meeting, hopefully, with to discuss different options. And today also we would get intro on how RFC 8795 does some of augmentations. And for the gap 5, I think there is need for some further analysis, because there is a bigger impact on topology. So maybe that can also be discussed in IETF 120 face-to-face. So Nigel has his own slides, but can I just finish a few of my slides still, Nigel, and then you can talk about.
Of course, no, Pushka.
Yeah.
No, Pushka.
So
I'll
Matt,
just.
How much time do we have? Because there are 2 minutes left normally for NMOP, which includes as well Nigel. So how much time could we give extra to complete Olga and Nigel?
If you can do that in 5 minutes, that will be really great and fair for Italo and the team.
Yeah.
That's
5 minutes for Olga and Nigel,
in total. Right? 5 minutes in total, yeah.
Yeah.
Yes.
You've got 20 seconds, Olga. Keep going.
Okay, sorry. We did start a little bit later, as far as I remember. So that's why. But sorry for taking the time. So this is the plan for hackathon. We discussed the hackathon, and we are proposing to kind of look at the Oscar's drafts and try to implement it. And one of the things is also how to connect potentially with IETF ISS and IETF OSPF. So this would be. This is kind of our current planning to start on hackathon and look for some others to join us as well. We have Oscar, Olga, and Sheriff, one guy from our team, to look for more. And then meeting that we want, side meeting really, that we want to do. So this is something. And summary of the next step is really probably repetition of some of the things, but closing any issues and submitting new versions, finalizing, analyzing, side meeting, before hackathon, doing everything needed for preparation, attending hackathon and presenting this proposal, not submitting this, but presenting this.
Okay, can I share now? Sorry.
Yes, please.
Urgently. Can you give me the can you let me share? I've asked to share. Stop screen share. I'll have to stop it. Okay. Oh, okay. I get it. Oh, come on. I've got to find the thing I want to share now.
I give you the slides control.
Select your slides. Is that some refinements? Is that the one actually, Ben? Sorry. Yeah, it is. It is great stuff. Okay, confirm. Okay. Okay, you should be able to see the slides now. Is that correct?
Right.
Yeah. So just scroll. I'll go quickly. I'll go very quickly through this. I've got 3 minutes, I think. So the purpose is to improve support for multi-point structures. There are some natural things that are naturally multi-point bidirectional, and it's to allow them to be represented efficiently, especially for information transfer and so on. That's what we've talked through this before, so I'll speed through this. From experience, we've with other work in other bodies Olga mentioned earlier, we've concluded that there is significant benefit from having that representation opportunity, and certainly digital map it will be beneficial. We know we've had some drivers to do this from some operators, etc. So essentially, it's the 8345 currently allows a representation of multi-point bidirectional with a collection of unidirectional point-to-point links in a pseudonode, and the proposal is simply to consolidate that complex collection into a single entity that then can describe its internal structure separately if necessary, but not burden the environment with loads and loads and loads of point-to-point unidirectional links. So, and so hence we've discussed that before. In the draft, well, it seems to have broken slightly. In the draft, there was a proposal for some yang. The red part is the addition. It was proposed to be added, not to be externally augmented, because it's supposed to be a normal part of the model. And we've been through this before as well, but just to point out the key features, and then I've got a couple of changes. There's a list of points. So the points of as an alternative to these are optional here. So I can either have this pair or the list of points. So it doesn't take away the opportunity to do what we currently do with 8345 at all. So it's an addition rather than a change or removal of any capability, as we said before. And the points have roles and direction within the context of the link. That's internally with respect to the internal behavior. The role is with respect to the internal behavior of the link. So you can deal with root leaf structures or with protected structures or any other structures where there's asymmetry in the internal behavior. And we had direction. During the discussions, oops, I didn't use that one. No, during the discussions, just picking out that the red bit's now gone black here. There was a recognition, Olga pointed out, the direction is essentially also a role, so should we not integrate those? So it would seem sensible to consider a list of point roles which include direction, so that would be a refinement to the refinements, which we would take into account in the work on the 8345 enhancement. So there are other roles as well which might want to be in that list related to protection, etc. So a list of roles is more sensible than a single role, and certainly incorporating direction as a role consideration would be more sensible too. So and then we need to change the structures as represented in the draft to allow for that list. And the roles, maybe to pick out importantly, the link type is essentially a reference to a specification. So ideally there would be a machine interpretable description of what that type meant, such that an advanced controller could navigate the description and understand how the link behaved, so understand its root and leafness from a navigation perspective, or understand its protection, asymmetry, or whatever else it happened to be. And the roles also reference, ideally reference machine interpretable specifications, but as that will take some time to get to, the intention is these allow for a string option and then a more formal option in future. So we need to prepare for that future.
Najir, please, if you could,
go ahead. Of course.
If you could
sorry.
wrap up, we really appreciate it.
Sorry, if I can. Sorry, I spoke over you. Sorry, if I can.
Just wrap up, yeah, so that we can move to the next.
Next sorry, one. Yes. Sorry. I've used even more time of asking you what you said. Sorry. So next steps: construct the enhancements to be integrated, set up the process so we know what the timelines are and so on, and make sure we engage a maximum of the community to ensure that everybody's comfortable with what we're doing. So we need to do that. I have one more slide beyond this, if I may, and there's a backup slide, but I won't use that. Additional things for further enhancements that we need to ensure we don't get in the way of when we do our work on 8345. So there's, I won't be able to go through each of these. We talked about direction. There's potential for termination direction to be incorporated. Specification of capabilities I mentioned. There's a question that we need to be very careful with here as to what the role of 8345 is in the solution. Is it describing a model for transfer of information, a model for navigation of a repository, or what? Each one has a different bias, and therefore we need to make sure we cover that carefully. And there's also a consideration of scale, where I've got very large structures where I may want to reverse the references, so not have the link pointing at the termination point, but have the termination pointing at the link, has an improved life cycle behavior and so on. But I think these are all, again, things that can be done additionally. So as long as we're careful with the way we do the modifications, we can then bring those as additions in future. That's all I had to say today. Yeah, so I've got a backup slide. So that's all I had today. Any questions in my -3 minutes?
Thank you, Nigel, for accommodating this. Yeah, just one I would say request is that you have shown a list of, I would say, candidate refinement to the various models. So far, we don't have any discussion on the mailing list on those.
No, that's right. I can do that.
So if you can just separate, I would say, the discussion points, not having the bulk of all of the items, but just separate them. This will be really see the kernel you can receive from the group. Yeah. Thank you.
I can open up a discussion on each one and see if any go anywhere. That's probably the best thing to do. And if any catch, then we can broaden the discussion and so on. But I can do that on the mailing list soon.
Yeah, thank you. I think that we can move to the next slot from Italo.
Okay. How can I share the slides?
I stopped for a start. I think I stopped. And then you request.
Okay, ask to share the screen. Okay. Okay. Can you see my screen?
Can now, yes.
Okay. Hi, everybody. I'm Zalo from Huawei. I'm presenting on behalf of the people who are active in the co-synthesis working group on the T-topology and tunnel model, and how the idea of this presentation is to show how the T-topology can be applicable to the use case for digital map. So a brief overview is that the idea was to manipulate the retriever and reading and changing the topology for TE, and it's a generic model that describes nodal links, which is the basis for augmentation of the specific technology models that like optical, but also MPLS-TE and SRTE, and it supports many features. So, for example, the possibility to describe native and customized topology, the possibility to abstract the topology, the underlay-overlay relationship for nodal links to allow the multi-layer navigation, interlayer modeling, and also interdomain model. So what happens if you have to build a multi-domain network topology by retrieving topologies from two different domain controllers? And the building block is generic attributes for the topology, for the link, and for the node. We also add a connectivity matrix to provide some connectivity constraints in the node, but also attributes in the link like the bandwidth, the administrative groups, and the SRLGs. And also we provide information about the information source, so where the information has been taken, that has the source of information that has been used to build the actual topology. So it means that you can represent in a topology view what you collect from OSPF-TE, ISIS, BGP, and so on. And for each information source, you also give a credibility preference that gives an idea about how, in case of conflict, how the conflicts has been resolved. So multi-layer support is a key requirement in T topology, in T networks. And so this is part, has been addressed. So as Olga said, this is not addressed in 8345, but has been addressed in 8795. So what we have the concept of the TP, which is the point where you have the interlayer adaptation factor.
Sorry, can I just give a comment? I can't. I don't think. I think it was that I said it wasn't addressed in 8345, like, because it's very generic.
Okay,
so,
yeah. But it's not very clear how do you do the multi-layer, yes. And here, what we do, we have the TTP is basically where you have the layer transition, and you have the adaptation capabilities between the two layers. And then you can use this entity to create the T tunnel in the server layer, which is basically the support of the client layer in the link in the client layer. This is a well-known multi-layer hierarchy in the networks, where you create a tunnel in the server layer, you have a link in the client, you have an adjacency in the client layer, and this is well described in the T topology and tunnel model.
Sorry to interrupt. I put my hand up, but I'll just hit down that slide. The client layer link is an 8345 link, isn't it? So you've got 8345 at the bottom on the diagram, essentially, and then you've got the internal, and then you've got 8345 again. So it alternates between pure 8345 and T additions, isn't it? You can make just to be clear.
Yes. If you manage the tunnel, yes. We have also provided the possibility to abstract. So if you have a multi-layer network which has composed by multiple nodes, you can abstract these, so you don't need to report a node for every physical and network elements. The most extreme abstraction is to abstract the whole network as a node, and then you can represent, for example, the connectivity between within the same layer, or between the endpoints, the tunnel termination points, and the link termination points. So you can, so since the topology, the node may not, an abstract node may not be able to support all the connectivity among the TPs, or the T characteristics of each source destination ingress egress point from the network will be different in the abstract node.
And sorry, do we ask question now, or do we wait?
It's okay. It's okay. We can.
Could you? I know I sent an email and we started that discussion already online. But what was the reason? Like, because my understanding of RFC 8345, and it was like the TMF, probably TP as a termination point, generic termination point. It was not LTP. It was called TP. So my assumption was that TP can then be LTP, TTP, CTP, GTP. What was the reason that you didn't want to reuse TP from the RFC 8345 and supporting relationship from RFC 8345, as it was kind of proposed originally to support the layered network and introduce the new concepts? Was there some reason? Sorry, could you remind us of the reason, please?
I don't remember the actual reason, but if I remember well, 8345 described the TP as the point where you terminate a link. That's maybe we can double check that.
That maybe it's just to come. That was exactly the point I was making, Flo. If you take link as an ITT link, then you end up where you are. If you take link as any old forwarding relationship, whether it's a potential or enabled flow, then you end up where Olga's thinking, I think, and it really depends how you interpret the word link. So I think that's the challenge we're grappling with, and I can see why you're where you are from that perspective. It's just I think we need to decide whether there's a generalized termination concept like the
like Google line, or like a link in any topology.
Is any old line, and
therefore if steep tunnel on the topology, you would have a link between two, so you have a node network TP and link on any layer topology as a generic concept.
Yeah, you have to be careful there. It's whether the topology is representing enabled forwarding, which the tunnel is, or that it's representing potential for enabled forwarding, which on Flow's diagram the link is, and an ITT link would be, where you can take the link and termination as a sort of generalized graph entities, where the link is the edge or the arc or whatever you want to use, and then any net graph can then yield to that model, and hence the tunnel is a link in that part.
And Nigel, yes, I think, well, all the design decision, I mean, is modeling. Okay, you can always do differently.
Yes, that's right. I know.
So no matter what you do, you can do differently. So at that, okay, the TTP and the LTP have, honestly speaking, different characteristics. And at that time it was decided to model them as two different topological
I wasn't
elements.
criticizing. I was just explaining.
I'm not saying that is wrong. I'm saying that I'm not saying that what you say is wrong. I'm not saying that what they did is what has been done in 87, 95.
No, I know. Nor was
it's
I.
just a different design decision. Yes, exactly.
That's right.
Yes.
Nor was I saying it was wrong. I was just pointing out where I think the complexity is that Olga is highlighting. I was just trying to pick it apart a bit.
No, for me, it was more about the question about the reasons, but okay, you answered in terms of definition of the link. Yeah.
Yes. And then we have also the concept, as I said, with 87, 95, you can report the native topology, like the topology on the POP, and the bottom. So you basically represent a node for each router and a link for each link between the routers. So you basically report the TD without any abstraction, or as I said before, you can do abstraction. So both options are supported by the draft, and you can also support a hierarchical relationship. So you don't always need to go through a tunnel model. You can also have, if you don't want to implement the tunnel model, you don't need to implement the tunnel model, or even not, you want to navigate between layers where you don't have a T-tunnel, you can also use the hierarchical, the support underlay link, and you can show that a link in the topology blue is actually supported by a path in the topology red, and a link in the topology red can also recursively supported by another path in topology green. And so this is also a way to represent a multi-layer topology without the need to go through a tunnel. And you can also show for every link what is going to be the primary and the secondary path in case you have protection switching in the server layer.
Yeah. Can I ask you something, Italo? Sorry to interrupt again.
Yeah, it's okay, it's okay.
Because we did POC kind of where we did different technologies at different layers, and we succeeded to do the POC with RFC 8345 only. And what we modeled is layer 2, layer 3, OSPI, size. Then we did T tunnels, but we also did MPLS LDP tunnels using the same modeling concepts, and then SRv6 tunnels. You are saying this is just for T, that LDP connectivity would have to be modeled using RFC 8345, or would you also be able to model MPLS LDP?
In the in the primary and secondary, so in the primary and secondary path and the underlay path, I don't see anything that requires the underlay path to be TE. Maybe I don't know if other people from TEs has a different opinion, but at least in the underlay, I don't see anything that requires a TE path.
Okay.
Then a bit of history. Okay, that's what is scaring me, to be very honest. Yeah.
It's all sorry. I couldn't get the mute off. Sorry. I think the important thing that Olga would then highlight is there's no reason to be inconsistent from layer to layer to layer. If I've got a model that represents an enabled forwarding thing that I happen to call a tunnel, then there's no reason why I shouldn't use that on all layers, and that would then fit with it would then be the connection.
Nigel, I have a slightly different opinion, because when you have an underlay T tunnel, the underlay T tunnel is something that you can manage, while when I see an LDP tunnel is something which is automatically built. So you can still
view it.
Yeah, you still need to manage it. You have events, you have assurance, you have configuration, you have, you enable it at different links as it goes.
I don't think you enable it. That's a key point. I think it's
you enable LDP.
You enable LDP,
yes,
yes.
on the interface. So
yeah,
in that case,
I understand. But as soon as you
your
enable
layering
LDP,
is very generic. If you think
but the management process is completely different. You enable LDP and you have a full mesh of LSPs.
No,
With
I
heat
agree
tunnel,
about that. I agree that processes are different and
Yeah.
functionality, but I'm just thinking, are the models different?
The
you
model
know?
can be, the representation can be the same. Just because the process of arriving at that model is different doesn't mean the representation can't be the same.
From the level of topology navigation, I would agree with you. From the level of path management, I'm not sure. Because I don't have the path management life cycle is completely different.
The entities can still be the same, even if the life cycle is different. That's all. I would argue that was true. The creation of some links might have to be manual because I can't do anything other than manually create them because they're in the physical
No,
world.
Nigel,
Yeah.
I'm not talking about the link. I'm not talking
No, I
about
know
the,
you're not. No, my
I'm
point was
talking about the path
my
management and not the
point
link.
was
The
my
topology.
point was the life cycle.
Yes,
My
the
point was the
topology
life
will be
cycle.
the same. I agree.
But my point was the life cycle of a link can be different. In some cases, they're manually created. In other cases, they emerge, and so on. So I was thinking that I've got two different life cycles, yet I can have the same model there. I don't see why I wouldn't have the same model when I got two different life cycles for the tunnel. In inverted commas, the thing that represents the enabled forwarding. I don't see a reason why I wouldn't do. And certainly in other bodies, we've had the same model, although they've got different life cycles.
Okay, we can discuss. I don't see. We can discuss.
We can clearly
discuss the
discuss it,
tunnel and see whether the life cycle is the same. My
I
understanding is completely
definitely
different, but
agree.
from the topology,
Italo,
it's the
sorry,
same.
I think absolutely you need different properties. You have policies, you have
That's right.
augmentations. Absolutely, every functional area has it. But in terms of do I have to go from one layer to another layer to the third layer and understand different concepts in different drafts and use in one supporting relationship and another underlay relationship, which
That's right.
model completely differently? And it's not then just for traffic engineering and what if I have to understand how do I have assurance relationship, let's say, in order to kind of connect to determine the root cause, and things like that. Every function would have to understand it, and it would be kind of a different augmentation. So I would have to say if it's MPLS-T or any other T, go this way.
Sorry, Olga, sorry, I disagree. Okay, as I said, from the topology perspective, you can have the same model. The underlay path, I don't see any difference. I can describe the underlay path of a link regardless of how the underlay path has been set up in the model. I don't see why it should be different. When we talk about the underlay path management is a different story. But for the topology point of view, if you want to navigate from the client link to the underlay path, you can do that regardless of how the underlay path has been configured. The topology provides you the information.
Okay, so we can still see it all as a topology. The only thing we'll be missing is traffic engineering part.
Yes, yeah. Yep.
But tunnels could still be seen as the links on top.
Exactly, correct, yes.
Okay, so from the perspective of the map, we don't need
From the perspective of the map, you don't need that, exactly, correct.
Okay,
yep.
Thanks. Or assurance, or okay, thanks.
Yep. But that's a good feedback. I think we need to take this into account maybe in the use case analysis. Okay, another point which is scaring me is that 8795 has been a long time effort. We had 5 years of intense discussion between people, and we were different views because the model is applicable for optical transport network, is also applicable for packet networks like IP, and some people are planning to use it on the device, and some people are planning to use it as a network. And we had to refactor requirements for different environments, and that was a long discussion. It was a long way ago, a long path forward, and I'm a little bit scared about restarting all this discussion again, because at the end of the day, we have all these layers, all these views are still in the network. And also notice that there is a big impact because many models are augmented 8795. As I mentioned before, I've done a review, but it's on an old version of the Excel file. But I have a rough estimation I have done based on the analysis done so far. We are almost 50% of the models which augmented 345 are also augmented 8795. So the impact on any change we do on 8345, which is not compatible with 8795, is quite relevant with respect to other models.
Sorry, so without putting my hand up, do you see any of the things we discussed today as being not compatible explicitly, where you're not just concerned they might not be, but you know they're not?
Yes, well, the bidirectional link I wrote in the chat, maybe we can discuss, is definitely not backward compatible and is definitely impacting 8795. Because if you have a bidirectional link with the properties which are asymmetric, I need to recreate all the constructs that we already have on the T-link to provide the property is the forward and the reverse direction, which are already there if I have two links.
But
for
you don't
example,
you don't need to use the bidirectional
so I need,
link in
so
that case.
well, yes, okay. So at the end of the day, yes, okay. Then we go into that direction, okay.
Yeah,
And,
we can
and
discuss that.
sorry,
We can discuss
Carlo,
that.
how did you get this 50%? Because I didn't get that number, so just wondering.
You can look at the draft and the Excel file I put on the comment, and we can continue the review on your. But you mentioned today, before you mentioned 44, 9 out of 44, 11 are not analyzed, and if those 11 are all also augmenting 87, 95, you get into 20 out of 44. So we may be close to 50%.
Okay.
So, yeah.
Thanks, and thank you very much for reviews.
Yeah.
Like
It was not difficult. It was a bit difficult to review the Excel because there are some drafts which have been obsoleted, some drafts have been replaced. So the counting was not that simple. So
you could filter it, just filter.
Yeah, but the status was not very clear. So maybe that's something. Maybe we need some guidelines about that, how to filter to do the counting. Yeah.
Okay, thank you very much.
Okay. Yes. Another important characteristic for the digital map is that if I look at what are your target as a digital map, I'm expecting what we say is a core multi-layer topology model. But when I look about multi-layer, I see that in a real network you can have T and no T layers in the same network.
Yes.
And you can have also, in some complex scenario, you can have also some interleaving. So some T layer and on top of non-T or vice versa. So that's so it's what I think is very hard to say. This solution having different solution for T and non-T layers for common requirements. And as I mentioned before, there are some attributes I think about SRG, but the bandwidth latency, which maybe now, if I look at the digital map requirements, I see their applicability also to non-T layers. Because if I want to do a what-if analysis, a typical what-if analysis, for example, how much is my network resilient to the failures? If you don't have the SRLG, you can have your what-if analysis will be completely broken. For example, you can see, oh, there is my network is very resilient because I have 3 redundant links, and then you discover that actually these 3 redundant links are sharing the risk. So these 3 redundant links are breaking all at the same time. So your network is going to be, even if it is connectionless, non-T, you can see in the what-if analysis, thanks to the SRG, that a single failure is going to partition your non-T network. And the SRG is the same information. It started and it was invented for TE because we wanted to be able to steer the traffic toward the path which are SRG disjoint, such as the 2 paths don't fail at the same time. But if I want to do what-if analysis, the same information element is still applicable also to non-T layers. And that's exactly the problem I see on the boundary between what is T and what is non-T when we discuss 8795. The information may be the same, and the usage of the information is different between a T application and a digital map or any other application people can think of on top of these information elements. So then we go and went and look at all the gaps that have been identified in 8345 in the drafts. So this is the summary of the gaps. I think we already seen in the presentation from Olga. And we started to analyze one by one. I don't know if you have time to analyze all of them, but I think we can continue if there is interest. I will try to give 10 to spend 10 minutes at the end on the profile and on the conclusion. So one issue is the bidirectional link. So 8345 has made a conscious decision to model bidirectional links as two unidirectional links between the same TPs. The T properties, as a consequence of this design decision 8345, we provide the T properties for each T links. So if you have a symmetric link, for as in the bottom, on one link we say the latency in 10 milliseconds, on the reverse direction we say the latency is 20 milliseconds. And this information applies to the underlay paths, because you can have a bidirectional link which is supported by two unidirectional paths.
Yes.
It applies to SRG, a bandwidth, and latency. All the properties that we have identified in 8795 can be potentially different between the two links. The problem is when the link is symmetrical, the link can be symmetrical or asymmetrical. So when I compare the solution proposed in NMOP from the existing solution 8795, I see that one potential advantage is only when the link is bidirectional and symmetrical.
No, as you know, Italy, sorry to interrupt. I put my hand up again before I spoke. But
It's okay. It's okay. I'm okay for interactive discussion.
Okay. So the as you know, in TAPI and other areas, we have unidirectional opportunity for unidirectional packages. So you say, well, in the case where it's bidirectional symmetric, you have one package saying the thing is the same both ways. Where it's different in different directions, you have two packages, one for A to Z and one for Z to A. So it's a lighter weight version of the two links. I still have the integrity of the single bidirectional entity, but I have a subdivision to deal with the asymmetries. And of course, the point of the specification model I made in the very brief presentation I gave was that it allows you to state asymmetries in an efficient way only to the depth where you need to state them. So if the thing's fully symmetric, it just says symmetric. If the thing's got asymmetries, then of course it breaks down into smaller pieces, but you therefore get an efficient representation of the symmetric cases.
The problem is only when it's symmetric, and we look at the case and the rules. There is a rule that you can be as efficient. So there is no efficiency. We are working on some JSON examples. We can see that the number of the lines codes is exactly the same.
Don't forget it's multi-point too, and some of the multi-point structures.
We're talking about bidirectional. Let's look at point-to-point bidirectional. There is no difference between there is no efficiency issue. That's the reality, especially considering that in many cases you have some asymmetry.
There's an efficiency issue from a lifecycle perspective. One entity represents both parts, and if it happens to be symmetric, I only have one statement. If it's asymmetric, I have two. There are few properties. They're not large volumes of data.
Yes, I would agree with Nigel, because if you think again about traffic engineering, if you think about path computation, and I agree, completely relevant to have a unidirectionality. But that's why if you look at different layers, at the tunnel layer, you will have unidirectionality, and then at the layers above and how it's used, you may need to have bidirectionality, so it all depends kind of, and especially if you're looking at the full life cycle in terms of how things are configured, how hardware is, how to link it and all of that. You may end up with in some layers requiring unidirectionality, but others may not.
That's fine, because as I said, the bidirectional link is modeled as two unidir. The unidirectional is modeled as a single link. And you have a common way to represent unidir and bidir, and you can easily understand that the link is bidir because you can see in the figure the two unidirectional links are ending on the same pairs of LTPs.
You have to be careful with easily. You have to navigate them to determine that. Whereas if you've got one bidirectional link, you don't have to navigate anything. It's clearly bidirectional.
Yeah, you need in the management, you need managed entity to manage it for configuration, for events, for faults, for all of these things. And which one do you connect to it? How do you relate to the symptom, to the alarm, to the incident, to the...
To be very, very clear, though, the proposal is not to replace unidirectional links with bidirectional. It's to add the opportunity for bidirectional links where it makes sense. And I'd argue there's many cases where it makes sense. I know that's a value judgment that we can all make separately, but the point here is always it's not forcing you to change your unidirectional links into bidirectional. It's simply giving an opportunity to represent things bidirectionally.
Yeah, that has to be very well scoped, because I know.
No, I agree.
No,
I agreed. I fully agree. Fully agree.
A clear example of bidirectional links is the optical network. Actually, what we notice in the optical impairments is true. OMS links are bidirectional, but in reality, the impairments and the list of OMS elements on the amplifiers that are traversed by the optical signal in the two directions are completely different. And when we worked on it in the optical impairments, which is optical network is one of the is the most common case where people talk about bidirectional link, we got it quite beneficial. It was a perfect fit, the current model, because we had each link, for each link we provide the list of OMS elements that have to be traversed in the OMS link in each direction. So even if when we have something which is bidirectional, it's bidirectional from management, but in reality is unidirectional properties.
I think so. I was going to agree with you that clearly everything's unidirectional, including termination points that are represented as bidirectional in 8345. I mean, everything is. Transistors are unidirectional, so I mean that's it basically.
Exactly.
The only thing that isn't unidirectional is the fiber, which is clearly potentially omnidirectional, bidirectional, but that's it. Everything else is uni.
Okay.
But that doesn't mean from a management control perspective you need to represent it as unidirectional, because it can end up being very inefficient. And clearly it's a life cycle thing.
I think maybe we need to qualify this inefficiency, because at this moment in time, for the point-to-point, we didn't get it. For the multi-point, okay, the current approach in 8345.
There are people in the queue.
Sorry.
Just one thing about time management, because you wanted to cover the 7 identified gaps, right? Yep. So I like the interactive discussions. So what do we want to do collectively? Because you have like 10 minutes more. This is your presentation, Italo. Okay. Do you want to go through one of them? I mean, two extra more?
Yeah, well, maybe one extra more, the conclusion, and then the T-topology profile. I think maybe it's enough.
All right. I believe, Matt, that you could have 5 extra minutes for this discussion by Italo. But this is your discussion, your presentation. If you want to get a question at the end, this is your call. If you want to go to one of them in details, but maybe maximum like 14 minutes.
Yep.
Okay. So you decide how you want to run the show.
Maybe I will show the next 2 slides and the conclusion, and I will take comments, the last comments on this presentation. Okay.
Your call.
Okay, then the other is a multi-point connectivity. The approach in 8345 is to model this as a pseudonode. It's explicitly stated there. And well, I agree with, I think Maja says something similar, that that's quite a high level, because you don't know all the, if the pseudonode is not a full mesh, then you have some limitation. But we already have in the T-topology the concept of connectivity matrix, where we can say which TPs of the pseudonode can connect with which TP on the pseudonode, and also what are the characteristics of that connection, which is very important if you want to do, again, the what-if analysis. And we have a common connectivity matrix, default connectivity matrix that avoids to specify common properties multiple times.
And can I make one comment, one very small comment, the point of the 8345 enhancement is to remove the need for the links on the outside of the pseudonode. If you look at the
that's fine.
The multi-pointed link as a pseudonode, then it's the same challenge.
Okay. So that's okay. Well, what we found is that the 2 links at the edge of the pseudonode has definitely a tax, so it's less efficient. But we go from O to N to O to 2 times N. So, well, as far as I know, in the scalability issues, the 2 times is usually not a concern. But okay, I suggest that we discuss. And then there is, we are open to discuss alternative options to remove that requirement. If the issue of pseudonode is the links at the edge, we are willing to, maybe in RFC 8795, to remove that limitation. And so let me go to the conclusion to save time. The conclusion, sorry, too fast. Okay, so as a conclusion, we think that if we reuse the 8795 in the context digital map, we can have a smooth integration in the digital map when we have a mix of T and no T layers. We don't even, we also don't create, we also do not have a problem of what do we do and how we reconcile the fact that we have solutions which are based on 8795 and solutions which are based on the new augmentations, how they live together. When do you use one and when you use the other? We found that most of the augmentation that are needed for the digital map are already present in the model. We are open and there is no position at this moment in time on any BIS or augmentation at 8795 to address gaps or improvements. But of course, we need to have more discussion on what is needed to improve the design. And the last point, which is introduced in the next presentation, is that the complexity take into account that there is a possibility to profile the T-topology model. So there is no need to implement the complete model when it is not needed. So the complexity is because we provide in one model a lot of features. And that's the next presentation will go into more into the detail about the profiling to make to say that you don't have to implement everything if you don't need everything. So if we can start with a small implementation of the model to small application.
Can I just quick question, Italo? Do you have any information? How many do you have the POCs, or is it used mostly in the products? Like when you were doing the RFC, like was it POCs for multi technologies?
I know that we had the POC for multi-domain OTN networks in China many years ago, and there have been a couple of POC in ETSI for the microwave networks that are using this topology model as the basis for microwave topology microwave and Ethernet topology discovery. That's something that is quite. I think it's quite public information. I don't know for the non-public information what I can disclose. So we can discuss that. I may send on the list some reference on these two public events. Okay. Are there comments or questions on this one? Sorry. If not, I can move to the next one. Oh, this one, sorry. What is the other one? There it is. Okay. Okay. Oops, not this one. Okay. Okay, so these slides are presenting the draft, which is a working group document draft in TIS, which is addressing the issue of profiling the T-topology model. Just to check, can you hear me?
Yeah, we can hear.
Okay, good. Okay, so what is the motivation for this draft? Is that this draft was started some years ago and revived recently and adopted recently because it's not the first time we are having this discussion. Actually, we had the same discussion where we had the microwave POC. The scenario is we are discussing scenario where we have non-T networks, but we found a lot of attributes which are needed to model a scenario, which are already defined in 8795. And there was the debate, or the model is too big, and we don't need all of the attributes, plus this is known for T. And this is more or less the same discussion we are having here. And we recognize that it is very true that at the first glance, the model appears too complex. And the reason why it appears too complex is because we support many features. It's not limited to few features or to one feature like many models. Some of these features are mainly for TE networks, but there are a lot of other features supported by the model which are applicable to TE and non-TE networks. And the boundary between these two subset of features, I think, is a little bit blurred, let me be very honest. And the model is anyhow designed to make most of these optional. So the reality is that you don't need to implement all the model if you want to support only a subset of it. So the intention of this draft is to clarify that if needed, it is possible to implement only a subset of this model and to address some specific scenario which may not be necessary TE use cases. And we have some example of non-TE scenarios when you want to model, describe the administrative and operational state of some topological element, which is missing in IETF 45, where you want to do multi-layer navigation like overlay and underlay topology, or when you want to describe nodes which have a switching limitation, like the pseudo node or like RODAM in an optical network. So these are a few. So you can see that if you have a small, the smaller is the requirement, the smaller is the profile that you have to implement. So, for example, administrative operational state, you can implement only 3-4 attributes per topological element. So it's a very tiny profile of the big model. The same for the overlay and underlay topology. You have two small enhancements. And also for the switching with a limitation, if you just want to say which TP can connect to which TP, you can see that the model, the profile is very limited. Of course, if you want to do everything, then it's like putting all the augmentation all together. You have a big model. That depends on how complex is your use cases. We also discuss some issues about the augmentation. For example, one option which is used quite extensively, for example, in the CCAMP working group, is that we augment the TE topology. By augmenting the TE topology, we still do not mandate the whole TE topology to be implemented, but you can still implement a profile of it. A good example is the microwave topology model, where it's actually documented which is the minimum, the subset of the TE topology which is needed for microwave network. Because microwave network is interesting, they even don't have any switching capability, but they still have the concept of links and they have the bandwidth of each link. So you can implement a subset of the topology, then you can augment that subset, and you can, for example, provide the augmentation to the bandwidth characteristics of the link, or to the TDP, or to the connectivity matrix. There is a second case. I think another example for this second case is the SRT topology model, where the technology-specific augmentation are all targeted to the topological constructs of 8345. So you have technology-specific augmentation only for node links and TPs. So you can create a model which augments also a network type under the network topology. Even if you have this model, that's not precluded to add to this model, when you implement it, some attributes from the TE topology, so a profile of it, through the multi-inheritance. So you create an instance which is instantiated both the technology-specific network topology type as well as the TE topology type, and you support and you implement only the subset of the TE topology attributes that you need. Again, you have a very simple way. You can add these attributes at any time. So you can also have a backward compatibility, because you can start your version 1 implementation with just the technology-specific network topology. I think about the layer 2, layer 3 topology models that have been used, the digital map, and then you say, oh, to navigate between these models, let's implement an TE topology profile and do a double augmentation. And then you are adding new attributes in the new release, which is fully backward compatible addition. We had an option 3, which is discussed in the model, where you can do an augment both have two augmentation, like as two models or two modules or two network types, one directly the network topology for the node, the links NTP, and one that augments the topology when you want to augment something which is in the T topology profile, the T topology like the bandwidth TTPs on the connectivity matrix. Splitting the augmentation into two models does not provide advantages compared to option 1, but we think this option 3 may be useful for backward compatibility. For example, you have already published a module that provides augmentation to the network topology, then you want to add new attributes which augments the T topology, then you can use option 3 to maintain backward compatibility, which you have already done. But if you go from scratch, option 1 looks much simpler than option 3, but we do not rule it out. It's just say that there is no advantages, and the model and the draft provides some guidelines on how to do that, and provide also some suggestion about where to put the augmentation attributes in the tree, depending on which option you are following. For example, on the link, you can put directly under the link if, for example, you don't want the T container to be instantiated, or you can put under the container if it is needed, or if you want to augment the bandwidth, of course, it has to be under the T container. So we have a few open issues. The first open issue is very interesting to me, is that the problem is how do you know, how can the server report to the client the profile it has implemented? There was an initial discussion on NetMod, but I don't think the feature is useful, because the feature is too coarse grain. Here the profile may be different for different instances or different network types. So, for example, if you have a microwave topology, you don't implement the connectivity matrix, but maybe you have to implement the connectivity matrix for the Ethernet topology, which are in the same provided by the same server. So, the proposal that we have in this is, we say this issue is important, but it's a little bit outside the scope of the draft, which is just informational and providing the information to that the profile can be created. But we think it may be worthwhile having some work either in NetMod or in Ops area or in an NMOP working group. We still don't know what is the right working group. Maybe it can be a good discussion for an SITF to find a more programmatic way to describing how do we profile the standard YAM models. So finding a solution that allows the server to notify the client on the profile. For the POC we worked on, this information about the profile implemented by the server was negotiated offline. So as part of the POC definition, we decided, we agreed on which profile we were going to implement. But in a real network, maybe it will be useful to have some formal language to exchange this information. And the second issue, I think, is also relevant to some of the questions was raised by Olga. There was a question about what is the difference between the supporting link, supporting node association, the relationship defined in 345, and the overlay underlay of 8795. And the proposal that we would like to add to this draft is to clarify that the overlay underlay is designed for the multi-layer, while the supporting node is used more for the model abstraction. So to represent what is the relationship between an abstract node and the underlay supporting node. That's the proposal that the authors have to clarify.
But they do say in RFC 345 underlay, overlay?
Okay, maybe, yeah. As I said, this is for discussion, yes. And because as you notice that is not complete, that relationship. And then, okay, what are the next steps? Okay, we are going to have adoption. We got some comments to the adoption poll. We are going to address them. We are planning to advertise this to other working group, and this is the first working group we are targeting. And we would like to trigger the war for the generic solution. And okay, of course, have new review. We can add other useful example. We are considering about the use cases for digital map. Here the doubt is whether to add these use cases to this draft or whether to create a new draft where we say how the 8795 can be used to support digital map use cases. This is maybe a subject for further discussion. How do we describe how T topology profile can be used for digital map? And that's all.
Do you have any hackathon or POC of this profile?
Well, basically all the hackathon, all the POCs I'm aware of the T topology model are basically implementing a profile. I'm not aware about an implementation that has implemented everything in 8795. Only some subset of it has been implemented based on the use cases.
But if I'm application, I still have to look at the RFC, is it, to understand it?
Yes, yes, yes. Yes, typically what we do with the profile was something like this. We show the subset of the tree, and we said, okay, let's implement, for example, let's implement these leaves. In 8795, we do not implement all the other leaves. Or if you implement the other leaves, let's ignore them in the POC. Because these are the one that provides the information that we care.
Okay, so we've got a few minutes left. So Matt, is it time to go to the next steps?
Yeah, I think it will be. So first of all, thank you, Olga, and the Nigel and Oscar and Italo for preparing this material. We see that there is, I would say, some gaps and bridges to, I would say, to share and to have the common understanding of the use cases and how the existing models, I would say, are accommodating this, I would say, the use cases. So at least for the next steps, I see at least three points that will be good to, if we can make some progress on them. The first one is to consolidate the use cases. So we do already have, I would say, the document from Olga with the digital map requirements and the various the core use cases to be modeled. So Olga, it will be really good if you can extract those and share them on the mailing list, both TS and NMOP, so that we can discuss and have a common understanding of the use cases. Then I guess the natural exercise from Italo, at least for the T topology, is to do an assessment based on those use cases to see to what extent we can provide these use cases with the current modeling status, if there are limitations or side effects or complications to accommodate other part of the use cases. The third use case, I would say, action points will be on the refinement candidates. Nigel presented a set of candidate items that may be subject to refinement in the existing topology models. We don't have discussions so far on this item, so it will be, I would suggest that, Nigel, if you can please share the list in the mailing list, if you can separate them so that we can ease the and track the various discussions on the candidate refinement. Some of them can be agreed upon, some of them can be just discarded, but we need to have the discussions, and we have to continue discussion between both the groups, the TS and the NMOP. So please, each time, make sure that both groups are really in sync and the same information is circulating in both groups. In this third action points, I also suggest that for the use case presented by Oscar, I see that Oscar is asking for, or at least considering for the adoption call for the OSPF and the ECS. At least as chairs, we don't have an idea whether this is the, I would say, the appropriate time or the appropriate group to consider the adoption of for this one. But we need to understand whether with the current, I would say, topology modeling, we can address the ESCS and the OSPF topology, or there are extensions that are required to do that job. So Oscar, please, if you can start a discussion on this and explain the rationale behind your request, and if there are limitations or extensions that are required for this. That will be also good to have in the before the next IETF meeting. So those, of course, there is just suggestion from our side, from Benoit and myself, and the discussion is really open, and we are open to receive feedback and suggestion for the next steps. I don't know if Pavan or Lou or Oscar as TS working group chairs, if you want to, if you want to say something on this, on how better we can synchronize, I would say, the discussion, that would be really welcome. Of course, so far we've done it informally, but yeah, if there are steps to better, I would say, consolidate the coordination, that would be something that we are considering. So please.
Yeah, first of all, thanks to both of you for facilitating the discussion. I think this is a good start. So we can continue the discussion on the list and see how we want to coordinate, maybe a side meeting, or try figure out ways to facilitate the face-to-face discussion in the upcoming meeting. We'll start with the discussion on the list, and then make a decision based on that.
Nigel?
Yeah, Matt, just to be clear, do you want me to send stuff to both NMOP and T's lists simultaneously? So we get the discussion between the two groups, or just keep it on NMOP, or what do you want to do with the...
So far, let's skip the two lists until we will decide in which list we will just keep the discussion.
Okay,
But at least for the background and the context, we need to have it synchronized.
Yeah, okay, I think that makes sense. I just sent an email to only NMOP. I'll just forward it, so I'll resend it to both. So I'll do that, and I'll carry on doing the other ones whilst we're going through. So, okay, thank you.
All right, so the crowd is quiet. Seems that we reached some sort of conclusion. Thank you for summarizing this, Matt. Any last feedback in the next 30 seconds? No, then thank you very much. So the meeting was recorded. We're going to write the meeting minutes. Let me share one last time where the meeting minutes are. So feel free to complement the meeting minutes with exactly what you said during the call. And let's use the mailing list more on this topic in NMOP and TS. Thank you all.
Thanks, bye.
Thank you very much. Bye.